Good morning, everyone. I can see by the turnout here that this is going to be a powerful presentation, so
no.
I'm excited for this. It's probably one of the biggest crowds I've seen in the last 3 days here at RSA, so bravo. My name is Pamela Fusco. I am part of the RSA Program Committee, and I'm here to introduce you to a very stellar speaker, as we're aware of. And I'm sure he's going to bring some powerful information here with everyone. So I want to introduce you to John Lambert, who is a distinguished engineer at Microsoft and a corporate vice president. I'll let him do the rest, and you have 50 minutes for this presentation. So I feel like it's going to hit right to the end. There may or may not be time for Q&A, but John says he'll do his best. So let's welcome John.
All right. Thank you. Okay. Hi, I'm John. I run the Microsoft Threat Intelligence Group, and I got to say I'm excited to be here. Thank you all for coming. I haven't been to RSA in a couple of years, and I got to say it's back. Like, that expo floor is just packed, and you're like trying to thread your way in. And all the great things about RSA were like in the security community, you get that security in your blood, and you see your colleagues from years gone by, and they're still coming, and you're still seeing them, and they may have different jobs at different companies. And then the other thing I notice in the expo floor is the carpet. You know, you're just walking, you're like, oh, the soft carpet. This is the great place to be. So RSA is wonderful. Today I'm going to talk about some changes in threat intelligence and its convergence with artificial intelligence. But I thought I would say one thing about innovation. RSA is a showcase for innovation, but did you know that Microsoft makes the #1 cybersecurity tool? The #1. If you look in any SOC, you will find this tool in every SOC. Do you know what it is? Any guesses? Word, okay. Any other guesses? Okay, well, I don't know if Excel. You will find Excel in every SOC everywhere. People use Excel to look at data. And so with that in mind, I went to the Office group and I was like, I don't know if you've been paying attention, but cyber is hot. Like, we should spin off Excel into a startup, call it Cyber Excel. We will make $1 billion, guaranteed. And then they looked at me and they said, John, that's a dumb idea. Excel makes $2 billion today. So with that, I wanted to start off by saying, like, if you're an observer on cybersecurity, it's hard to find the good news sometimes. There's a lot of doom and gloom, in the media about cybersecurity, and I would say, and yet every day there are stories of success. Defenders are quietly sharing information. They're raising costs for attackers, and they're evicting them earlier and earlier. And these are some of my favorite stories from the last year or so, where one of the perpetrators behind the ransomware attack on Kaseya and its customers was arrested. Now, normally, these ransomware actors are hidden in places where there's no extradition, you're not going to get them, but this, I would say, threat intelligence work, international law enforcement cooperation, this person traveled into a country where he was arrested as soon as he got at the airport there. And so, in another case, the FBI infiltrated the Hive ransomware gang's infrastructure. And so this is ransomware that was used to attack many different organizations. And the FBI used its access covertly to obtain decryption keys for that ransomware, was able to provide those to victims, denying that gang over $130 million in payments. And then another one that I'll talk about later in this session is Cobalt Strike. Raise of hands for those of you familiar, heard of, like, hate Cobalt Strike. Yes? Okay, so Cobalt Strike, popular red team toolkit. It's very featureful, has a lot of abilities and stealth, and as a result, cracked copies of it show up on the internet, and they're used by ransomware and nation states in cyber attacks. Well, the company that makes Cobalt Strike, Fortra, they don't like that. At Microsoft, we don't like that. And the health ISAC representing victims of ransomware attacks didn't like that. And so we all joined together as plaintiffs in a suit to get these sites taken down. And I'll tell you more about that. So threat intelligence is making a difference. The dwell time in networks by attackers, like maybe it was 10 years ago, it used to be 200 days these attackers would lurk in networks, and now that's down to around 20 days. So there's a lot, I think, a lot of proof points of progress here. But those are some backwards-looking stories. If we look forward and want to forecast what's going to come in the world of threat intelligence, you need great data and you need great analysis. And like, I love this analogy with weather because in a ways I'm so impressed how good weather forecasting has got. Like, if I want to go on a hike or I'm in my hometown of Bellevue in the greater Seattle area, the weather will say it's going to start raining in 21 minutes in your neighborhood and it's going to stop raining 37 minutes later. And I'm like, how do they know that? That's like super hyper specific. And of course it's because of the improvements in the capabilities of weather forecasting. And there's a great analogy here to cybersecurity, I think, because if you look at where weather forecasting has gone, in the ancient days it was like half astrology, and that evolved into almanacs, recording the weathers over the year to try to guess about the future. But it was really the advent of scientific approaches that improved weather prediction. So there was an arc of improvement in measurement. An early measurement in weather was maybe a windsock or a rainfall catcher, and that turned into scientific measurement on airspeed, the invention of the barometer, Doppler radar, and that arc of measurement permits better data to be gathered. And then data for weather is good, but you need to aggregate it to be able to make predictions and know what's going on. You got to do it very quickly, because if you only aggregate the data and it takes you 3 days to do that, it's hard to make a forecast about tomorrow with it. And so information sharing also had an arc of improvement in weather, where they went from writing this stuff down to the telegraph, to the invention of the radio, and then the internet to transmit it. And then turning that data into answers, that was an arc of going from sort of superstition, like the wind out of the east is cold because that's where the sun comes from, or something like that, to mathematical modeling of the weather. And this graphic here that's in the middle bottom, does anybody recognize that, know what that is? Anybody? Shout it out if you do. This is called a Lorentz attractor, or a strange attractor. This has its origins in chaos theory and mathematics, and it was Edward Lorenz, who was a weather forecaster and mathematician. He discovered that his algorithms and nonlinear equations were very sensitive to high precision decimal points. Think like 3, 4, 5 decimal points down the road. And if you only model things with less precision, eventually over time, as you played those algorithms forward, they would diverge dramatically. And here are these two wings of the butterfly. This is, the butterfly flaps its wings, and in New York it rains. Those wings are the stability points that suddenly it will switch from being stable to unstable around another point of stability. And I think, I love it because it's relevant for this, and I love it because it reminds me of the world of security and incident response, where normally you're operating and you're defending every day, and then suddenly an incident happens and you're in a completely different tempo with a completely different rule book, and then you don't know how it's going to end, but it does, and then you go back into normal time. And so today in the world of cybersecurity, I think these 3 trends have really underwritten this moment of threat intelligence and AI. And I think of them as 3 stacked forces that are coming together. What I mean by stacked forces are things that are they're good on their own, but they're all accelerating each other. And my best analogy for this would be, if you think about yourself, if you get good sleep, you're going to have more energy. And if you have more energy, you're going to be able to exercise. And if you exercise, you're going to have better health outcomes overall. So any one of those is a good thing, but they all help each other get better. And here, the 3 stacked forces that I think have underwritten this moment is data at scale, threat intel, and AI. And by data at scale, that is really, the cost of storing data is really down to pennies, and that's been driven by this hyperscale competition among cloud providers to really drive storage of all kinds down very cheaply. And that cheaper storage allows a lot of high-resolution sensors, where you can suddenly collect from megabytes to gigabytes, per device, user, et cetera. And the rise of XDR and SIEM means we now have data across the entire digital estate, from endpoint to app to cloud to identity to IoT. And this bonanza in data, that's just surface area for threat intelligence. And then you can apply that threat intel over that surface area, and you're going to get better signal of attack. And that signal then becomes the labels and the training data for machine learning and AI. And so they all work very well together, because like what TI can find, AI can help scale. So I'm going to walk you through I'm going to zoom in and kind of double click on threat intel here. But I first wanted to introduce that we recently introduced a new taxonomy in how we're talking about threat actors at Microsoft, and you'll see that in the upcoming slides here. And we did it for a few reasons. Let me start by saying we take a multidisciplinary approach to threat intelligence at Microsoft. We have threat researchers that know reverse engineering, speak the languages of cyber, next to applied scientists, data scientists, machine learning. We're also complemented by a team of geopolitical experts with linguist skills and disinformation experts. So this allows us to take a whole of adversary approach in cyber, and that, in a way, is behind the reason we needed to restructure how we talked about threats. We also talked to customers about how we name our threats, and they wanted to see improvements as well. So some of the feedback that we got is, Microsoft learned that your Strontium is APT28, is Fancy Bear, but if you say what's Actinium, I just have no idea, like no clue. And they wanted from us just more immediate context. So when we name a threat actor, they just know right away more about it. And so for nation-state threat actors, they all have a family name now. And so you'll see us refer to an actor, something Typhoon. Well, that is an actor originating out of China. I'll talk about Mid-Sandstorm here in a minute. That is an actor coming out of Iran. Midnight Blizzard, that would be an actor coming out of Russia. So right away, with the family name, you know whether it's nation-state, and if so, which one. You know if it's cybercrime, those we refer to with the Tempest family name, or if it's influence operations or disinfo or what have you. So this provides more immediate context. The other thing they wanted from us is they just wanted to be able to search and find the information better. One, if you know, we tended to name our actors off of the periodic table, and we liked it, people liked it. It's sort of scientific and not super flashy and whatnot. And part of the problem with that is if you search for zinc, that's a North Korean actor. The search results are probably going to give you sunscreen, you know? And so we needed ways that the names would be easier for people to search, discover, find, and remember. And the last thing I would say is we needed the taxonomy to represent the scale of threat actors that we were seeing. So you see it's integrated across cyber, nation state, cybercrime, disinfo, public sector offensive actors like NSO Group, and so on. And some hard limitations we were running into is we use elements for nation state threat groups. Now, we say we track 160 nation-state groups. There's only 118 elements on the periodic table. So we were definitely going to have to do something no matter what. And so this gives us a better namespace here. Change is always hard to swallow. And so in addition to documenting this and using it at Microsoft and in how we're going to communicate about threats, we also if you have names of groups you're more familiar with, you like and track CrowdStrike's name or Mandiant's names, we will provide those AKAs anytime we talk about a threat actor that we think the threat we're talking about is the same as that threat group. If we believe there's high correspondence, we will provide that. Also, we have digitized tools to make it easy for machines to go with this change, where there's a JSON file now where that has all these mappings in it, including all the AKAs for the other groups. And there's an API for threat actors now in the Microsoft Graph that you can call, and you can get these intel profiles on these actors and information about the AKAs. So let me talk about a threat actor and use one of these ones from this taxonomy. And I'm going to talk about a threat actor called Mint Sandstorm. We previously used to call them Phosphorus. They are the Iranian Revolutionary Guard Corps, and they represent a number of cyber threat groups in there. You may have heard of them as referred to as Charming Kitten or APT 35 and 42. And so this is an actor based out of Iran. I'll tell you a little bit of an origin story, like why did we pick Mint Sandstorm? Where did that name come from? Some of the names have an origin story, and some of them are just a name out of a hat. But this one, Sandstorm, is the family name for Iran. So that's that. And the first word, you could think of it as an adjective. I was corrected by somebody after we published a taxonomy and said, Mint Sandstorm, mint is not an adjective, John. Mint is a noun adjunct. And I was a math major and I was not an English major and I did not know that, but now I know. Mint is not an adjective, it's a noun. Okay, so noun adjunct. Those come from a list that an analyst can pick when we promote a group. So like there's colors, flavors, fabrics, patterns, that's sort of the universe of words there. The original name they picked was Sage Sandstorm. Sage Sandstorm. Now, analysts are going to say these names a lot. And try to say Sage Sandstorm 3 times fast. So that tongue twister got changed to Mint Sandstorm. So that's the story on that. So what I want to tell you about Mint Sandstorm today is that this group, IRGC, which is composed of a number of different subgroups within it in cyber, they traditionally target activists, dissidents, enemies of the regime, journalists, defense industrial base, and they have a very, I would say, straightforward way that they go after targets, mass phishing campaigns, luring you to websites to gather username and password. But what I'm talking about here is a subgroup inside of Mint Sandstorm that we were able to resolve and stood out. And I don't want to use the word sophisticated because everybody hates using that word with APT, but it's different than the rest of Mint Sandstorm. And it's different in a few ways. One way that it's different is they showed an ability to rapidly target enterprise applications with vulnerabilities that had recently released proof of concepts, exploits for them. And so sometimes they would weaponize those end days on the same day that POC was published. Or sometimes within a couple of days, and they could turn that around in an op tempo to go use against targets. And if you think an enterprise application, if that's on the attack surface and it's not patched, this is going to allow them to get elevated writes, some critical data right away, and really facilitate lateral movement inside an organization. That's one. A lot of the other groups in Mint Sandstorm use off-the-shelf malware. They had access to a dev team that built custom malware. We call that DrocBK and Soldier, and I'll talk about that more in a second. But the ability to quickly, rapidly build custom malware to support their operations. And they, instead of blasting out thousands of phishing mails, they would really be very selective about who they went after. So that's sort of the technical and operational aspects that distinguish them from the rest of the cluster of Mint Sandstorm groups. The other thing that we noticed was they had a sudden shift in targeting from about mid-2021 to mid-2022. And they went from going after activists and dissidents and journalists to targeting almost exclusively US critical infrastructure. And so they were able to use those techniques I mentioned to penetrate multiple seaports in the United States on the West Coast and the East Coast, transportation companies and energy companies in the United States. And one thing about some of those targets, any target could have intelligence value, right? There's something there that could have, for cyber espionage purposes, but some targets are more valuable from an effects perspective, from the ability to do disruption from that and the impacts from that. And you go, well, what was the reason for that shift in targeting? I'll tell you some of the things that were going on in Iran at the same time that co-occurred with that. So one is there was a new national security apparatus that was a bit more hard line, and so there may have been more freedom of action to this group. The second thing that was going on is there was a number of disruptive cyber attacks in Iran. And so if you remember, there was an attack on the Iranian railways that disrupted that. There was a cyber attack on gas pumps in Iran where gas pumps stopped working, and it would display some message on the gas pump itself. And then a seaport had its activity interrupted. And they blamed the attack on the gas pumps on the U.S. and Israel. So that's sort of the backdrop behind this shift in targeting that we saw. Now, these attacks and these into these organizations I mentioned in the United States, it didn't result in disruption. And perhaps that's because all of these organizations were notified about these attacks, and they were able to go intervene in time and evict these actors from the network. It also maybe they decided not to pull the trigger on some of them for one reason or another. But this is a little bit more about the attack chain that Mint Sandstorm uses, and a little bit more about their tools. And so it starts here on the left-hand side with an exploit for maybe an enterprise application with a very recent vulnerability that people haven't patched. And then they kind of had two different attack chains here. One, they would come in and use PowerShell, and then either go dump credentials from your Active Directory and orchestrate command and control over SSH. Or in this path here, they would go embed into a network and use their DROCBK or Soldier malware that they would tailor, and they would do their command and control over the web. And they often would use public internet services, like they would put the domains for command and control on some place on GitHub. And then they would download that file off of GitHub, and that would have a list of domains for them to rotate through. And so the end organization is faced with how do they block all of GitHub? That may be bad, but how do they know this is happening? So this is a little bit about the tradecraft that we saw there. So that's Mint Sandstorm. Like I said, Sandstorm is now our family name for Iran, and Mint is a reference to one of the groups there. I want to now give you an example of a group that is in development. And so every threat intel shop has a way that they often start with a cluster of activity, and they have some way that they assign nomenclature to that. We used to call them dev groups, so this would have been Dev 1101. Now we are referring to them as storms in our weather taxonomy, so Storm 1101. Mandiant would call them UNCs for uncategorized, UNC 2452, and eventually over time they may coalesce several of these storms together for us and promote them into a cybercrime actor that becomes something Tempest, for example, or a new nation state, or coalesce with an existing threat group. So let me tell you a little bit about Storm 1101. So they make a very popular toolkit for bypassing multi-factor authentication. And so I remember giving a presentation during the pandemic, and it was like this good news and bad news moment. I was like, the good news on multi-factor authentication is that this era of remote work and remote access has doubled the rates of multi-factor authentication. And we're like, security people, we've been talking about this forever. We should feel good. What a great moment. The bad was it doubled it from 7 to 14%. Now it's around 30%, but you can see still a long way to go on the adoption of MFA. But even at that rate, as security conscious organizations put it on, it is now an obstacle to threat groups. And so they're building circumventions for multi-factor authentication, including this technique called adversary in the middle, AITM. And I'll explain a little bit about this, what this technique is, and this slide and a few more. So the idea behind phishing, of course, is user clicks a link, they go to a lookalike site, they think it's the legit one, they type their credentials in, and then the bad guy has their creds and then can go and use them. With adversary in the middle, it starts off very similar. User gets a link, they click it, it goes to a lookalike site. Now, if they had MFA, think about a classic phishing attack with MFA. They would type their username and password in because they think they're on the right place. And then when the bad guy goes to reuse that, they would get challenged with the MFA prompt. And they would say, type in the code that's only on your phone. And they don't have that user's phone, so the attack stops right there. Well, the way adversary in the middle works is the user clicks the link. Now they're on the bad guy's website. They think it's the legit website. They type their username and password into it. Once the once this website in the middle, this proxy, what they do is they just proxy that logon to the actual site that they want to log on to, and they supply that username and password. And then that site says, well, now I'm going to issue an MFA challenge to the user's phone. So then the user gets the challenge on their phone. This is what they expect. They think they're logging on. So they take that code, they type that code into the attacker's website, and the attacker proxies that onto the legit website. And then the consequence of that is now that logon has successfully passed MFA. And most MFA logon schemes, you don't have to MFA on every single page that you go to, you MFA once. And the way that that often works is the logon service gives you back a session cookie that stays in your browser that is the proof that you did MFA. And that proof, that secret, that session cookie now goes to the adversary in the middle. And they can then go access this thing for as long as that session cookie is valid for. And that session, they don't have to do MFA again because that session cookie has claims that they did MFA. And so this technique is referred to as adversary in the middle. And this is showing you intercepted here, and then the attacker will then take it and then either exfiltrate email, or they'll do some business email compromise attack, or what have you. Okay, so Storm 1101, they're like, man, this MFA thing is a thing. I think there's a market opportunity for MFA bypasses. So they built a toolkit, an adversary in the middle toolkit, and they advertised it on Telegram. And at first, they charged $100, subscription business model though, right? So $100 a month to get access to this. And they started adding features to it to make it more robust. So they know that security software is going to recognize those websites and try to poke and prod them, so they added anti-bot capabilities. They added CAPTCHAs to their rogue web logon pages because they want their real victims, they'll be able to solve the CAPTCHA, but they don't want security software to be a headless security software scanning stuff to be able to solve the CAPTCHA. So they want to deny them access to the ultimate logon page, which of course will be recognized as a spoof. And so they started to add all these features to it. Like any good vendor, once it got popular, they raised their prices. Now $100, did we say $100? $300 a month. And actually we got a Cadillac E5, not VIP version of it, that's $1,000 a month. And so very, very popular toolkit. And then this is a little bit more about the actual flow of how adversary in the middle works. And I'll make sure these slides are posted after this. But you can see the interactions from the user to the rogue phishing site and how it interacts with the legit target website the user wants to log into here. There are also open source versions of this kind of thing that red teamers and pen testers use. Evil Jinx is a very popular one. So this is an example of an actor we're tracking because they make a toolkit that then goes to a number of different cyber criminal actors across the ecosystem. And we want to track the developments of this kit so that we can have robust defenses for them. And as a result, we give them our Storm nomenclature. Okay, let me talk about the third threat story here. So I asked about Cobalt Strike earlier. So Cobalt Strike is a very popular red team toolkit. It's only sold to red teams. It's actually not sold to defenders. It's not sold to security companies. You can't say, hey, give me a copy of this so I can make sure my product blocks it. It's sold to red teams, and that's so it'll continue to be effective. That's just the way they do it. And it's very feature-rich, extensible, and so as a result, bad guys have, for a number of reasons, have decided to adopt this toolkit. One is it's got a lot of functionality, so they like that. Another is it allows them to kind of blend in. Like I'll say, as a threat intelligence professional, there's nothing we love more than custom malware. Like custom malware, like I talked about earlier with Mint Sandstorm, we love it when the attacker uses custom malware because that really dials us into we know who we're talking about and dealing with right away. When they use very prevalent malware, living off the land techniques, or in this case, Cobalt Strike, you go, well, who is this? Is this, and this is an example of some of the groups we've seen use it. So Midnight Blizzard, that's Nobelium, the actor we track behind the SolarWinds attacks. They used, you can see here, this was from our blog during SolarWinds, of how they had a lot of different tailored versions of Cobalt Strike that was used. Iridium, this is a sandworm actor, destructive actor. We call them now Seashell Blizzard. I'll tell you a little bit of an origin story on some of these names here. So Seashell Blizzard, AKA sandworm. So Blizzard is the family name for Russia, so that explains that part. And at first, the analysts wanted to call them Sand Blizzard because sand would be appropriate for sandworm. But we also had Sandstorm for Iran. So you go, okay, that could be confusing. And so, again, they have a list of names to pick words from. And so they chose seashell because what do seashells turn into if they're left on the beach for a long time? You got it. So, but we've seen a number of threat actors. These are some from Russia, but China, Iran, Vietnam, and a lot of different ransomware gangs use these cracked versions of Cobalt Strike that are then uploaded to websites for criminal use. And so we joined forces with a little bit of a consortium to go after this. So what we did is Fortra, the company that makes Cobalt Strike, they didn't like anything about this, but they didn't have the intelligence on what are the harms and who is it happening to. So we, Microsoft, we had the intelligence about how Cobalt Strike is being used by all these different actors that I mentioned, and could speak to the breadth and scope of this, and the linkages between people downloading these specific crack kits and their usage in cyber attacks. And then the Health ISAC, they saw and had cataloged like over 68 ransomware attacks in 19 countries using Cobalt Strike, ransomware against healthcare organizations. And so we had the vendor who makes it and owns the trademarks associated with it. That's important. We had us with the intelligence, and then we had the healthcare ISAC with the victims. We were able to go to the court and ask and use a number of different statutes, copyright law, DMCA. We actually had a racketeering charge in there for the first time to allow us the ability to go take these websites down that are hosting these cracked Cobalt Strikes. So let me ask, anybody in here a lawyer? Raise a hand. It's a safe place. You can raise your hand. It's okay. Nobody? No. Do you know a lawyer? Okay, if you know a lawyer, okay, all right. So I'm just saying, if you're a lawyer and you want to know, like, how do I do the cyber stuff too? That seems like exciting what you do. Talk to that lawyer, get that keyboard. You can go into action with stuff like this and make a dent in cybercrime. So, and this is an example of the attack chain that we would see here, or like a prototype of it, where the attacker would land inside a network, they would get presence on a network, and then they would use these cracked versions of Cobalt Strike, and a lot of times these were handoff operations. And so somebody would get initial access into a target. And ransomware, it's not like a set of threat actors, it's an evil economy. You have access brokers, you have people that make toolkit, you have operators, and so there might be a handoff that says, okay, we're in this network, and then somebody says, yeah, I'd like to try to get some ransom money out of that. And then that's handed off to another group who's better at the hands-on keyboard, lateral movement, privilege escalation, and ultimately, then that goes to another set of specialists who can do the negotiations with the victim on the ransom payment. So we would tie all these things together here. Okay, so that's a story on Cobalt Strike and how we're went after that. I want to pivot a little bit to talk about artificial intelligence. And so I'm sure most of you have tracked, and if it's not on half of the booths at RSA, it will be on all the booths next year, talking about how they all using generative AI. And I will say, as somebody that has been I've been at Microsoft 22 years in security, machine learning, it's just like everybody understands how to use it. You know what part of the problem you can use it on. You know the technology. You know the kind of things it's good at and where it has its limitations. And it's a normal part of building products and detecting and working on cyber threats. But there are a couple things about machine learning that make this generative AI moment different, I think. One is machine learning is like I said, it's always been there, but it's always been deep inside the technology. You didn't really interact with it directly. And if at the end of the day you're looking at some alerts or triaging something or something got blocked, you don't know if it was like some wizardry with a regex or it was ML, and it didn't really matter to you as an end defender how that was. And then the other thing about it was you couldn't go in there and start to ask it questions. You know, you always had these ML models were really very task-built and task-oriented. So they were good at detecting a phishing site or a password spray, but they had to be trained in these very specific tasks and domain. And these days, we're in a world of foundation models that are very broadly trained, maybe take 6 to 9 months of crunching data to build one of these models. And that's going to be a huge change for defenders. So some of the first things about this generative AI for security is, the first is that you can interact with it in your natural language. Normally in the world of cyber defense, you got to learn some domain-specific language. You got to learn Splunk. You got to learn the Kusto query language. You got to learn TC. You got to learn some domain-specific language in order to get through the cyber of whatever you're using. And so that is a skills barrier and a sort of a skills mastery journey. With generative AI, you can just ask it questions in your native language. And it can translate that and work over different data. And it can take the intent in your question and turn that into a Splunk query or a KQL query that can go then against a data set. And if you've seen the GitHub Copilot or heard about that, that's this code writing Copilot. And that is like, as a developer, you're like, well, I want to compare 2 dates and account for leap years and da-da-da. You just write a comment that says what you want to do, and then it generates the code for you. And I would say, if there's any audience that would be skeptical about whether this AI stuff would work, it's going to be developers. They know how fragile tech is, but I will say they have found it. They know that the generated code may not be 100% right, but guess what? Their code is not necessarily 100% right when they do it. If they go into it that mindset, it just makes them super more productive. It's like having like a pair programmer next to you that's helping you along with the things that you're doing. And if you think about how we upskill defenders, imagine you had something you could ask in plain English about threat intelligence, ask about these actors, what's this Min-Sandstorm thing, tell me how AITM works, and it's like an expert that you'll never annoy and is there all the time that you can ask these questions of. And so I think for the skills mastery and skills building, this will like flatten the curve of mastery for that and also help people just get better at their job. And if they're better at their job, they can command higher pay. And so I think all of this is really good for cyber. The thing that is true about all these, like if you use ChatGPT, these models are built at a certain period in time. And so the model may be 6 months old. And that means it doesn't know about the thing that happened yesterday. You can't ask it about the weather today. And in cyber, it's pretty useless to have something that is not current. And so all of these systems will start to have a skills library for them. And the skills are going to be the connectors that give it access to the external world or to your data. And so you think about like your Alexa device. You can ask Alexa what the weather is or sports scores or whatever. That's because it has a set of skills on the back end that know how to take an input, a prompt, and then translate it to an answer and bring that back. And this generative AI and security, there'll be a race to connect it to all the data sets that you know. And as organizations, you're going to have to make choices about where is this AI running? How is it secured? How is it compliant? What do I connect it to? Where does that data, how is it brought in? And how am I happy with that? And then also, you're not going to say, hey, AI, use skill X and skill Y to solve this problem. You're going to ask it a question. And part of the invention that's going to happen in this area over the next year is going to be these skills planners that are going to try to take that query, that prompt and go, what skills do we need to invoke on what data that was in that prompt? Like, oh, you put an IP address in, maybe we need to go get something out of that, or see if there's alerts that we have related to that user account. So that the planner and orchestration part will be a heavy part of invention. Those will go off and fetch data, and then GPT or these large language models will do their thing to summarize or try to best answer the question at the end of that. And so one of the things I would tell you that is a little mind-blowing if you haven't played with this stuff is in this world of large language models, many companies are building them and they run them against these benchmarks. And if they get like 0.5% of improvement on a benchmark, that is hard fought ground that they gained. And there was one research paper that said, hey, if you do this, you can get like 4 or 5 percentage point gain. And this one thing was just adding 3 words to what you would type in the prompt before. And the 3 words were, show your steps. And so you imagine, like, you ask, imagine you give one of these large language models a question like from high school math, like Joe has 20 red balls and he gives 3 of them to Susie and then, takes 4 of them home. How many does he have left, kind of thing? And at some point, these AIs would get this wrong. But if you just add the word and show your steps, suddenly the planners in there would walk through and explain the steps, and the math got more accurate. And so now many of these large language models, behind the scenes or explicit in the prompt, you say show your steps, explain your reasoning. And that chain of reasoning leads to more accurate results. And it's weird how eerie that is, like how humans work. Because if I said, hey, take the number 103 and subtract 17 from it and do that 3 more times, and then tell me the answer, you might try to do it in your head and then you might be right or might be wrong. But if you did it once and then you said what that was, and then you said, okay, that number, now do it again, and you just walk through it step by step, you get more accurate results. And so this world is a world of, they call this prompt engineering. Prompts are what you type in, and the right words that you put in there to help this thing be more successful, what you're doing, is a huge part of this world. And a thing I would say is it's going to lead to careers that we didn't even knew existed like 5 years from now, where somebody that's coming out of college is like, hi, I'm an AI red team prompt engineer. That's what I do. And we're like, we didn't even know this was a job 5 years ago. This is an example from the security copilot that we have. So here, this is, I know it's hard to read, but I'll narrate it, which is there's a suspicious login that's part of an attack chain. And you can see here there's a prompt at the bottom. And you can just type, like, summarize the incident and display the attack chain. And then there are skills that are fetching alerts associated with these things, the incident data, and then and you said, show the attack chain. Okay, and so then it renders that into a visualization. I think this used GraphViz and Dot to produce it. And then it can go and figure out what's the entry point for this. A thing about these large language models, and you'll see this if you use ChatGPT, is if you ask it a question and you get back kind of an unsatisfactory answer, the second step to do is to improve it is just ask a better question. And it's remarkable how that is like in real life. Like if you went to some team and said, how do we improve X by 10% or whatever, you might get some answers out of them, but you'd say, well, how do we do it by working with this other team? Or how do we do it using this particular approach? Or using OKRs or whatever it is. Like you'll just get a better question is going to get you a better answer, and it's large language models work the same way. And then this is an example where somebody, I think, talked about Word, Excel. This is PowerPoint, where you can say, summarize this incident in a PowerPoint, summarize it, and then show me the attack chain for it. And these things know, because they've learned from the internet, how to build Word documents, how to build PDFs, how to build PowerPoint files, and it's using the summary abilities of the large language model itself in order to condense that incident down into those bullets, and then it can pick out the attack chain and render that. That's part of this. Now, this would have been not super impressive if, like, we spent a year coming up with something to do this very specific task, but that's what's different about generative AI versus machine learning. And this is a third example, just showing it like, okay, if that's incidents, tell me, like, how do I secure my environment given what's going on? And it answering by saying, you deploy some attack surface rules. That should help improve the security health of the machine and the antivirus that's running on, and make sure that baseline is secure. Or move from people being admin users to standard users to stop some sort of privilege escalation and dumping of credentials on that machine and so on. And you can ask these things about, how does AITM work? How does a password spray work? How does this threat intelligence group do this kind of attack? Summarize their TTPs. What are countermeasures for, like, this is where this world is going. And how do you attach it to your data so you feel safe about where that's going and how that's interacting? And then how do the different parts of your security world across compliance, risk management, the SOC, Tier 1, Tier 2, Tier 3, how do they begin to incorporate this into it? So I will say, like, I haven't seen technology in my time at Microsoft where the first time I saw it in action, I was like, I don't know how it's doing, what it's doing. Like, I'm not sure how it does that. And this, the technology's obviously been in the works for many, many years in the AI community and whatnot, but it is the time for breadth application is really here. So thank you for all being patient. Thank you for coming. If you have any questions, maybe we can take a couple now, or I'll be here after, and I'll be happy to take more questions. 5 minutes. Okay, we got 5 minutes for questions.
Thank you for the session. I have a question. When you mentioned like prompt engineering, right, that made me think about like AdWords was good, in the search engine AdWords was very key. Now looks like the prompts are going to be the new ads. How are we going to ensure that it's not biased by what I'm searching for and the result is going to be biased towards a certain industry, certain...
You said, how is it?
How is it not going to be biased? Because if you look at the AdWords, right, you can pay money for the ad so that your ads come in the top, in the Google search, for example. With the prompt, you could do that as well, right?
Yeah, I mean, there's a few things about this world of prompt engineering. One is obviously many security practitioners are how do you abuse the prompt and trick the prompt. And we've had to add guardrails onto the prompt so that you don't just get willy-nilly what these models can do, because we want to avoid certain kinds of content, for example, or in the world of cybersecurity, it's very important that it be very precise and as accurate as possible. And if you see what Bing's done, they have a knob now where it goes from like, be creative, where you could say, hey, invent a story about a unicorn that flies over in 3 paragraphs, or you can ask it to be precise, where you really care more about facts and references, and security will certainly want that. And we'll see many different people connect this to data sets, and that connecting is command injection flows, so people will be able to add prompts. You have to make sure that they're safe, so you can't do, the equivalent of cross-site scripting and SSRF through these things. But the other thing is we're going to have to make these prompts and have users understand how to use them successfully. And so all of these will have a feedback loop in them. There's like a thumbs up, thumbs down, tell you why you didn't like the answer. And sometimes it's going to be, we just need more skills, to help answer that question. We don't have any way to access the data. And some of it will be better descriptions of those skills so the planners know how to choose it and orchestrate it better. So but it's the user in control of the prompt here. That's the thing. And so unlike in SEO or these other domains where you're trying to influence some back-end ranking of stuff, but I'm sure, like, as people hook this up to data sets, those data sets will become target for manipulation as well. Yep.
Thank you. Just for FYI, there are already in LinkedIn, you could see posts, here are the best prompts that you could use for searches for ChatGPT. So the prompt engineering is happening already.
Yep.
Thank you.
Yep. Thank you. Okay, last question here, yeah.
Oh, can I ask one question quickly?
Yep.
Or are you done?
Yeah, go ahead.
Yeah, no, so thank you so much for your talk. And, I really see a lot of what's been talking about here as a way for upskilling people, where there's only so few of us. One of the things I see a lot is that as people implement different security tools, there are certain signature behaviors that happen in their environment because they've implemented that tool. Like you have to have certain groups, you have to have certain things set up. So for AI prompting, is that something that you've thought about? And then also too, in terms of AI versus AI prompts can they think about what an AI is most likely to suggest and therefore work around that, or vice versa?
Yeah, I think when you say work around it, you mean an adversary work around it kind of thing?
Well, so they're going to have this too, right? They can write their own prompts. And so
Yeah.
if they say, what's the best malware to go after a target, and then you have an AI on the defense side saying, what's the best way to protect against this certain thing? And now you're in this sort of like,
in a way, like
chatbots talking to chatbots, right? Like, are they aware of this and actually able to?
Yeah, I think it's hard to be on stage and predict what the future of bad guys using AI is going to be, because I feel like in 3 years it'll be proven wrong. But I mean, one thing is people have already said, well, what about AI writing malware, you know, or phishing or what have you? But the reality is bad guys don't need AI to help them do any of those things. Like they have no problem writing phishing sites with automation or malware, polymorphic malware or whatnot. The thing that this helps defenders do is defenders have access to all their data and the attacker doesn't. And so that's an asymmetry that benefits the defender in this case. Right. And it's often the challenge is just like, how do I get out of that zoo of data the answer that I need now and the context and pull all that together? And then how many skills do I need to know as a defender in order to orchestrate that across every silo and tool and product and portal to do it? And where you have something that has a more general level of knowledge and connectors across those things, I feel like it's just a better platform that defenders will be on in order to be able to do those things. So,
Thank you.
okay, I'll be around for a little bit longer if you have questions. Thank you all.